Well, good afternoon, everyone. I'm Karl Harshman, and how do you advance slides? Okay. I will be talking about the Mission Operations Center at the Advanced Applied Research Building. I keep wanting to call it advanced because we are doing a lot of advanced research there. So welcome to the Applied/Advanced Research Building. All right. So this is something I've been thinking about for a long, long time. I've been at the university for over 25 years now and have been involved in numerous different missions, the longest of which is Mars Odyssey. I was involved in Messenger, Lunar Reconnaissance Orbiter, which is actually still going. The Phoenix mission, which went to the North Pole of Mars, where we did some digging and we found water, and the water was present right there after the lander landed, because the thrusters blew the regolith away and there was ice. So that was pretty exciting. Mars Reconnaissance Orbiter, and lastly, which is still going, OSIRIS-REx. And speaking of acronyms, I was working on OSIRIS-REx for at least 2 years before I understood what OSIRIS-REx stood for. And if you ask me to repeat it, I could get maybe half of it now. But the one thing that we'd never done was mission operations. We had done science operations on all of these missions, and we had done them very successfully. So, finally, what came up? The Applied Research Building. And guess what that had in it? A Mission Operations Center room with a server area, which was secure. All the security that you needed to run either ITAR missions, even non-ITAR missions where you need a little bit of security. So the entire building is, there are multiple levels of security. You need a badge to get in through the front. There'll be someone staffed at the front desk all the time. You'll need to have a badge when you're walking around it. To get to the various different floors, you need different levels of credentials to get in. And certain rooms will need additional credentials. So quite secure. And, it was like, all right, we can do this. And Joellen Russell isn't here, but we were all part of the design team for this building, and this was one of her little pet projects. She always wanted to have a mission operations room that looked just like the ones that you see on television, with all these NASA engineers sitting around looking at a huge wall of monitors. So anyway. So once I had this in place, that we have something that we could actually, where we could put a mission operations center, and the university spent quite a bit of money to put this building up. So figured, well, let's go for it. So what do we need? We need to find the personnel to make it happen. So I had a choice of some people that are very versed in the areas where they're going to be fitting in. One of which, Andrew Gardner, which was here earlier, he'll be architecting most of the software to be able to do this. Have Eva McDonough. She's our database administrator, and she will be standing up the database that we'll be needing for this to house all the data from the missions that we will be conducting there. And for support, there was Emily Joseph, and we've been working on this for, probably close to a year now. And, I should say that this was all made possible through ASI. They're giving us the support to do this, and the university itself, because, we have this great facility that we certainly need to make the best of and promote in the best possible way that we can. So, what we did, Hop Bailey and I, we created a budget for what it's going to take to stand up mission operations, proposed that to Tim Swindle, and he said, okay, go for it. And we said, thank you very much. So that was the money. we needed to have that to employ all the people that were going to be doing this. And then what else? You know, if you have Mission Operations Center and all you have is the building and the center itself, but you don't really have a mission. So we had to go out and we had to find a mission that would want to partner with us to be able to do their mission operations from here. And I need to give Carlos Vargas a great thank you because he hooked us up with Elisa, I'm sorry, I forget her last name at the moment, but it's the Pandora mission. So we were very grateful and we put in the proposal to be able to do their mission operations from here. And they thankfully accepted the proposal. So we are set to go. We have the mission that we need. Of course, the most important part is to have the mission. And this is a picture. The door there is going into the Mission Operations Center room. This is just kind of a lounge area outside of it, which you will occasionally need if you've been sitting there doing lots of intense mission operations and your data's coming in and you're waiting for the critical piece that is 10 minutes late. You'll want to go out and relax a little bit and then hop back in there. This is the actual mission operations room. The left side is looking forward to the monitor wall. This monitor wall can be configured in quite a few different ways. We can have 5 different things projected on it. Each of the monitors doesn't have to project its own. It can be split in the middle. So it's a very, very modern AV system. The room, you can see one of the mics there, and you can see the video in the front. So this is a fairly modern system, and we were very grateful to have that. If you look at the picture on the right, that's looking out towards the back. And the windows there are overlooking the high bays where they're going to hang their balloons. And all the way to the west side, there's another glass partition. And inside of that is there are cubicle areas, which some of the engineers will probably be wanting to make use of occasionally. Also some additional meeting areas. So our first partner, and I like to consider the missions that we're going to have as partners. They're not our customers. We want to partner with them and make as much possible for them as we can. We're not here to make money. We'd like to make enough to cover our own expenses, but our main goal is to be a partner with any mission that comes into this center, and we will do everything that we can to make it as successful as possible. We're kind of courting the Pioneer class missions, which are small sats, the CubeSats. So when we put together our budget for what we were going to be charging each of the missions, we took the amount of money that a Pioneer class mission will receive and tried to make it a reasonable amount so that they were not completely, so we weren't taking 10% of their budget. There's another university that is doing a mission operations center. You may have heard of LASP. It's University of Denver in Boulder. The mission that we have, Pandora, said initially they were given a budget from them, which was very, very reasonable. And then just before they got past phase A, they were given another budget, which was completely outrageous. It was more like 10 times of what they had originally proposed. So we're trying to keep it in the area where a small sat or a CubeSat could actually afford for to have us do the mission operations from here. So anyway, Pioneer is a Pandora is a mission class mission. And Pandora is not an acronym for anything, just in case you might be wondering. They're going to be doing exoplanet transmission spectroscopy. So watching as planets go in front of a star in the solar system so that they can get more characteristics out of it. So the PI is from Goddard Space Flight Center. GSFC, for those of you that are inclined to use acronyms occasionally. The COI is from Ames Research Center. And the management will be Lawrence Livermore Laboratory in California. So we will be using KSAT Lite to transmit commanding to the spacecraft and to receive the telemetry from it. So basic flow of a mission operations center. You'll see that the mission operations center is in the middle. We get the data from the spacecraft, and this is kind of close to what the Pandora spacecraft is going to look like. It will send down telemetry, send up telemetry through KSAT. We send the commanding there. We receive the data at the Mach, and from there we transmit it to the 3 different entities that are going to be operating Pandora: Goddard, Ames, and Lawrence Livermore. And we will be receiving the command products from the entities that have built the spacecraft. The commanding that they're going to be providing us is to command the instrument. We will be totally responsible for commanding the spacecraft. And we will be getting that information from Blue Canyon Technologies. And you may have heard they're now part of Raytheon, but we hope to be able to as much partner with them as possible. If not necessarily partnering, we hope to at least get as much information out of them. We're still waiting for the NDA for them to be able to start sending us information. So what does Mach consist of? So we're planning on standing up a database that will house all of the data. This has always been central to something that I've always done on all the different missions I've worked on. A database is basically in the middle of everything that happens. If you put everything into there, even if you don't know what to do with it yet, at least it's there when you figure it out. So you can retrieve it in whatever format you might want. We will have to do the spacecraft command creation. We'll have to verify the commanding. And I don't believe that we're going to have a spacecraft EDU. Lockheed Martin calls them STLs, Spacecraft Test Laboratory. They're called FlatSats by some other entities and stuff like that. I doubt that we will have those, so we're going to work on trying to make it as robust as possible as we can. And we can do this from understanding what state the instrument and the spacecraft can go to from wherever it might be. So, we definitely want to avoid the states that it's not supposed to be transitioning to. We'll have to do flight rule checking. Then we transmit the commanding through KSAT up to Pandora. And KSAT Lite is a radio. They have a antennas mostly throughout. Well, they're all throughout Earth, but we'll primarily be using the one in Svalbard, which is up in Norway, off an island there, since we will have a polar orbit. As data's coming in, we have to do limit checking on the engineering data, which means that if something's out of range, we're notified right away. And that lets us, that gives us a quick indication that there may be a problem with the spacecraft or the instrument in some way. So we'll automate that, and hopefully we don't get too many emails in the middle of the night or telephone calls in the middle of the night. There was one story from a long time ago. We had just launched Mars Odyssey, and Chuck and someone else were doing some commanding, and they tried to call me in the middle of the night, and my wife picked it up, and she hung the phone right back up on them. Anyway, we try to avoid that, but because of the low budget that we have to be able to do this, we're limiting our access from 8 to 5 standard working hours. There is absolutely no way that we could do 24/7 shifts for the budget that we've given them, and they do understand that. Let's see, mission packet check or missing packet checking, retransmit requests, the data distribution, which is really pretty simple. We receive the data, we send it back out. As we've done with Mars Odyssey since it launched. Then we're also going to be providing a database query capability, which will be online. So if someone has missed, if one of these 3 entities has missed their data, they can requery it. We'll have the engineering trending, which will be a web page. Our servers, we are in the process of procuring. A couple of guys in the back of the room are working hard to get that in so that we can get started on all this. And we will also have backups. And I've already mentioned that we have multiple security layers at the ARB. So in conclusion, here's our break room. And if any of you happen to have worked with me on OSIRIS-REx, we had a stand-up meeting every Friday. And Bashar Risk had taken it upon himself to bring in donuts every Friday, which we all enjoyed. So anyway, there are the donuts, there's the break room. Enjoy. And of course, there is the sales pitch that has to go along with this. Now that we have a mission operations center at the University of Arizona, if any of you are thinking of proposing new missions or are part of another mission, please think about us. We would love to have more than one mission that we could work on, especially if it's a smaller mission. I don't think we could do the high-rise or OSIRIS-REx type missions from this building, but we can certainly do the smaller type mid-X, things like that. So there's a sign-up sheet at the back. If you're ready for your mission, let me know. I'll hand out cards and stuff like that, so you know who to ask to partner with for your Mission Operations Center. Thank you very much. Yes, Buell. Yes, it is people, and it's all about being able to use those people in multiple areas. So no one in the Mission Operations Center, wait, there will be a couple of people that'll be full-time, but that's about it. Otherwise it just doesn't work. So we need to keep all these other missions going, and the more missions we have in the Mission Operations Center, the more personnel that we'll be able to keep there full-time. We are signing up to a fixed price. We are taking on the risk, and we have gotten we've been fortunate enough to have ASI be able to help us out to get this started up. So once we do have the mission, we just have to provide some mission-specific software to work with those missions. So that's where we will have our cost savings. Any other questions? There is a lot of space in ARB. Most of it is already called for. So I don't know if we could accommodate that there. When we were proposing Zephyr SOS, we were working with Ball Aerospace, and they also said that they were not going to provide us an STL. So that's where I came up with the idea of understanding what state the spacecraft and the instrument is in, and making sure that you understand which state you're going to be putting it in by whatever commands you're issuing, and not allow those commands to be issued. An STL is always really useful, unless it, well, you always have to remember that an STL is not the flight. So it's not the flight item. So you don't ever test anything exactly as it's going to be operating in space.